Hello and welcome back to the Rockcode Academy. My name is David Flanagan, although I also go by the handle Rockcode. Go figure. And today is the launch of our third course at the Academy, and we are taking a look at BGP. BGP is a really cool technology that probably or does provide the foundation of scaling your applications to the edge and globally. All right. For today's first session, we're doing things a little bit different, and we do have a guest. I can't find my mouse. There we go. And you enable that option where you kind of spiral it around and it goes pulsely big. But anyway, that's for another day. Yeah, we're doing things a little bit differently. I'm joined by a guest, friend and former colleague, Jeremy Tanner. Hey, how's it going?
Not bad at all. Good afternoon to you. Good morning to me.
All right. Well, I
Um,
mean, thank you for joining me today. It's nice that we get to do something together. You know, full disclosure, Jeremy and I work together at Equinix. So we've done plenty of streams together. We met up recently in Austin, which was awesome. When I was visiting CDCon. So nice to see you again.
yeah, absolutely. I'm ready to hear more about BGP and BGP and Equinix Metal. I got up. Well, I was gonna say got some coffee, but first I went and looked, and I was like, did the thing that everyone needs to do, which is follow Raw Code Academy on LinkedIn. All of the socials. Like that's where the stream needs to go,
Well, you know, for so
and then
long,
coffee.
yeah. For so long, I've always just streamed to YouTube. Uh, but I think for course material, I want to push it a bit broader and wider. Especially as what I'm finding is I'm having to update some of the older videos, and YouTube really doesn't like it when you have to do that. We're going to just digress now for the first 5 minutes. What I want to do is just live stream it to multiple places. We're out on LinkedIn, we're out on Twitter, we're out on YouTube, and then what we'll do is I'm going to edit this back. I'm going to stick it on Vimeo, and I'm going to make it available on the new Rock Code Academy website, which will be launching next week. So trying to do things a little bit differently as I've done for the last 18 months and just experiment. And yeah, this is the first course I'm going to do it with, but it should be good. All right,
Perfect.
back on topic. For anyone who is not familiar with you, can you just give us the TLDR of who is Jeremy Tanner?
Excellent. I like motorcycles and mountains and have two small copies of myself, but you're probably really looking for. Have been helping people understand bare metal and bare metal accessories at Equinix Metal inside Equinix, the world's digital infrastructure company, and now based in Austin, Texas. And yeah, certainly open to questions, meeting new friends, and today hearing about BGP.
Yeah, I mean, I hope you're prepared slides because I haven't. Uh-oh. Well, here's my first favorite feature of LinkedIn streaming. LinkedIn user says hello there. Hello, LinkedIn user. Um, I'm assuming we don't get that name on the API, but we do have some regulars. We have Noel, hey Noel, Russell, hey Russell. Another LinkedIn user saying LinkedIn is slow on the uptake though. Well, yeah, they don't have usernames. So I guess that'll come in the future. We
That's a
got a
premium feature.
Stefan, hey man. Hello to both. It's very kind. And a good morning from Steve. Hey, Steve. All right. So people must be wondering, the LinkedIn user is Chris Mulgrew. Well, yeah, LinkedIn users, if you are watching, feel free to stick your name and a colon at the start of every message. We'll just pretend that that's going to work for today. No, there's too many comments. I'm okay. I'm only going to show 2 more comments. We're going to talk BGP now. Please tell us about motorcycles. Yeah, we will get another stream for that. I reckon Jeremy could go on for a while. Cool. All right. How does this course work? Well, much like the other 2 courses, if you go to the Rockcode Academy GitHub page at github.com/rockcodeacademy, there is a courses page. As you'll see, we have our InfluxDB, our teleport course, and now our global reach with BGP. Now, of course, we're going to be spinning up some bare metal for this course so that we can actually use BGP and route traffic to it. So this is not like the other courses where you could just run a container with the software. Unfortunately, BGP requires hardware and other stuff, but it is invaluable to learn. So we have with Equinix Metal a code here of raw code. really difficult to remember. But if you go to the Equinix Metal website by clicking the link, you can click Get Started twice. And there's a coupon code thing here. Let me make that bigger. Stick a raw code in that box, fill in the rest of your details. No credit card is required, and you'll get $200. I just closed my browser. Oh, it's all right. You get $200 of credit. So that $200 is going to do you well. I'm just going to go to the console now. We'll get you $200 of credit. I think you can get 400 hours of compute for that. I think the C3 smalls are about 50 cents an hour. Jeremy can correct me if he wishes. So yeah, 400 hours for you to experiment with BGP.
Yeah, most recently variable depending on where you are, more in some places, less in others, but more for larger machines, less for smaller, but certainly in that ballpark.
All right. Can't believe I closed that window. See, I was saying just before we went live, I was considering a 3 p.m. coffee. I feel like I made the wrong decision by not having that coffee, but we're going to move on. Okay, so step one is sign up. Use the coupon, make sure you get those credits. And now today we're going to do the first 2 parts of this course. So we're going to do a bit of a conversation between Jeremy and I where we talk about what is BGP, how the routing works, all the stuff that you kind of need to know before you start deploying it. And then in the latter part of this stream, we'll actually do our first BGP deployment. So we will deploy multiple servers in multiple regions. And what we're going to show you is how the routing works, the latency is kept low, and this is how you scale your applications globally, or to use that wonderful word of the moment, edge, or at least as close to the edge as we're going to get. All right, introduction to BGP. Yeah, just absolute cop out here, right? Just stick in the Wikipedia definition and then just ask people to read it. I actually read the Wikipedia definition and I was like, that is super complicated. Like, does that really tell people what BGP is? Is it for people that already know BGP but want a primer? Like, for people that don't know BGP, I don't think it's that great. However, what I did know, and here's a cool trick. Are you aware of Wikipedia Simple? I assume you are.
No, I've not run across it.
All right, so you can do Wikipedia. Let's just go to the BGP page, right? And sometimes you just get all this nonsense and you're like, Border Gateway Protocol is a standardized exterior gateway protocol designed to exchange written blah, 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 right? Doesn't always help you, right? Especially when you get into some of the more like complicated mathematical or physics topics, which I randomly do because I just get too curious. But you can swap out the language, EN, for simple. And usually, it's not great in this case, but usually you get a very simplified definition of the thing that you're looking at. So it's a cool wee trick. There's also a Scots language one, but I doubt there's a Scots language for BGP.
Oh, does it have to be localized into simple?
I don't know what I did there. Is that just simple to... Okay, oh yeah, hold on. Oh, I replaced too much.
So simple counts as a language,
yes.
And just like French, Italian, or Scots. Okay.
Well, apparently Scots doesn't work in, but there is a Scots version. Anyway, small digression again. That's just why I'm not joined by people. It's too easy for us to go down other paths. But a comment there from Pavan. Today I learned Wikipedia Simple. Yeah, it's a cool trick, especially for those more complicated things. So, glad I could help. Okay, so rather than us reading verbatim that Wikipedia description, people can read it if they want. I figured you and I could just talk about what problem does BGP actually solve. Like, people are here because they want to learn the technology, but they probably want to learn it because they have a problem to solve. And I figured we could just kind of roughly explain that. And what I've done in this README document is try to, in a simple fashion, describe what happens when you request a website on a browser. So maybe we can just kind of go over this and we can add extra flavor or details depending on how we feel. Sound good to you?
Sure.
Cool. So what I've said here is let's consider what happens when a request for a website is made from your machine. This is high level. I know that people get asked this and like interview questions, and people have failed it because they didn't talk about electrons and electricity and all that stuff. I guess interview people, they take it too far. I decided to do it in 3 steps. So I probably failed the Amazon interview or whoever asked this. But first, we got a DNS request. So when we type in console.equinix.com, google.com, whatever, those words really mean nothing to the internet. What we need to do is a DNS lookup to get some sort of IP address, which is how all the magic of the internet works. Our browser will then send an HTTP request to that IP address, and it uses a host header. I don't know why I included that detail. I mean, it's correct, but probably not pertinent to this conversation. However, that server will eventually respond back with some HTML. Our browser renders it, and things are happy. All right, Jeremy, how does the internet work?
So the first thing I would like, so the IP given by the DNS, the IP address given by the DNS system, first of all, can be one of multiple IP addresses, but you can't. Which one is given isn't determined on any sort of basis. It can be either at random or semi-random, but you're not. I don't think you're segmenting by anything there. Additionally, I suppose it's important to say that you need to be able to reach your DNS server, and your DNS server is in your settings as an IP address. So how do you make the DNS request to the DNS server at the DNS's IP address?
Wow, things just got meta very quickly. Yeah, I think actually, this is actually part 3 of the course. Is where we're going to implement our own globally distributed kind of DNS lookups. We won't go into that in too much detail, but you're right. Your DNS server has an IP address, and we have to route that and answer that as quickly as possible and keep our latency low. So it's a really good use case for BGP. All right, what waffle do I have next to this README? Oh yeah, there's a lot of DNS servers. Your ISP is going to have a couple. It's all distributed. It's all cached. All this other stuff. And then I include some latency figures. All right. These figures I got from Wonder Network, which is a really cool website I wasn't familiar with. But you can actually add all your own cities, which I thought was nice. You're in Austin.
Yep.
I'm in Glasgow. I don't know if there'll be a Glasgow. I guess we'll do London. And now we can drop Barcelona. And don't know why I'm going through all this effort just to show our ping times, but there we go. So not bad, considering that, our connections are governed by the laws of physics and the speed of light. A connection latency between our 2 cities is only 118 milliseconds. Pretty good.
You can make that so slightly larger.
Oh yeah.
The monitor is small. I'm not sure what sort of Death Star readout there is in a.
You can right click on it and say show controls and then full screen it if you want. I should have told you that before we went live. But yeah, so 180 milliseconds. So I found this website just while I was putting some stuff together for this course. And it's a really good way to understand the latency between you and your customers. And let's talk about latency is just what the the amount of time that is required for all requests to happen. So while the latency of 118 milliseconds seems quite small, if your web page is making tens, hundreds, thousands, tens of thousands of connections to resources, at least when the connection has to be opened, etc., it can add up really, really quickly. Which is why, if you Google for why does Australia have slow internet, it's because all the products that they're using are in San Francisco and Europe, etc. So, maybe I'm sure there are lots of Australian data centers, but we all use products from American companies and European companies as well. So they notoriously have quite bad speeds with some of our services, which is why we need to decrease that latency. So you can see London to New York is only 70. LA and Austin are around that mark, Tokyo, and then Sydney. So it just keeps growing again because it is governed by the law of physics.
And is that best case or worst case? So a lot of those are maybe like IBX to IBX or data center to data center, more so than you're going to probably have more hops in there, depending on if you're on a residential internet plan or your business or whatever. It's unlikely that you're right in the data center where those pages or services are hosted.
Yeah, we've not even talked about hops. You know, when we do some trace routes later, we can definitely break that down. But to answer your question, it looks like this website does 30 pings to the destination. It displays the average, and then it's got some extra scores for lowest, average ping, etc. So the details are there if you really, really want to get into it. But what this means, and I think, you know, I think what I'm trying to highlight, I mean, I wrote the damn doc, I should know what I'm highlighting, but is that if you're building a product that is global scale, and that means customers and users of your service, then you need to improve the performance for people in the furthest parts from your servers. And that just means deploying to more locations, but not just deploying to more locations, is that you then have to be able to route the traffic to those locations when the customers are in those locations. Like, you don't want to go to a central location and then redirect them, which we used to see a lot in the 2010s, early 2010s, is that you would go to, like, I'm not going to say Google because I don't think they ever did this, but, you know, Yahoo or something. You go to yahoo.com and then you're redirected to eu.yahoo.co.uk or whatever like that. And that was all just handled that way. So that was a simple way of doing it. BGP is much nicer solution. All right. So, yeah. So this is why we have CDNs. Now, I'm assuming anyone watching this course is probably familiar with a CDN. The idea being that, you know, we host static websites, as an example, on S3 buckets or even just Nginx servers, but then we stick something in front of it like Cloudflare, CloudFront, Fastly. There are others. They cache all of those stuff. Those have their proxies running in many, many locations around the world. And your customers hit them instead of your centralized server, improving their performance. And how these CDNs work is all BGP. Go figure. The fourth part of this course is we will be implementing and building our own CDN. So after today, we'll do our own DNS servers with BGP. We'll build our own CDN with BGP. And the last part of this course will be building our own edge functions. So your own edge Lambda product using BGP as well. Anything you want to add?
I don't think so. CDN's good. CDN's closer to user, and yes, I mean, I ran into this when I think we ran into each other previously in Spain during conference time, and I was having a really slow time because was using the VPN that's in California, which is not close to Spain at all. And so if I switched it for the week to Madrid, and all good again.
Cool. All right, the last part of this document before we actually do something interesting with this is just to kind of talk about how BGP works. So when we want to send a request to an IP address, the internet, the mystical internet, has to route that traffic for you. So what typically happens is your browser makes a request to your ISP. Within the ISP, there's likely an autonomous system. Autonomous systems are routers, essentially, that know how to route traffic within their own network. They do this based on prefixes. So we got an example here as this router or autonomous system will say, hey, I know all of these prefixes, 123.0/24, and it keeps the traffic within the autonomous system. If there is a prefix that it doesn't understand, it's going to reach out to its peers and say, do you know this prefix? And when those peers come back and say, oh, yeah, I'm responsible for this prefix that will route the traffic to there, or it may say, oh, I know someone else is responsible for this prefix, and it starts to route the traffic through all of these autonomous systems until eventually you get to the server. And what you want is a company which has a very intelligent backbone with a good number of peers where those prefixes can be resolved and as many and as less or little hops as possible. Because the less hops that you do, the faster or the less the latency will be. And that's where Equinix comes in. Equinix has one of, in fact, probably the most substantial internet backbone in the world. I can't think of another. So, and that's because Equinix works with Google, Amazon, Cloudflare, all these other people too, I believe. Don't quote me on that. You can quote Jeremy on that if he agrees, but not.
I was going to say, I'm not sure there's anybody that we don't, but
Yeah,
partner team is standing by.
yeah. Equinix is the internet, so they have a good network for this. So what we're going to do today is set up a global IP, which just means it's an IP address that Equinix will broadcast to us within all the autonomous systems that they own and peer with, and we should be able to see some traffic routing. Now, I know this is a lot of words, so I decided to do some diagrams to try and show how this works. Now, what this diagram assumes is that your application has an EU server, a US server, and an Australian server. And what happens is our clients make requests in the UK and Germany to their ISP. Their ISP either has their own autonomous system or paired with other autonomous systems that are already within the EU. And because our infrastructure provider, such as Equinix Metal, is advertising our prefix to these autonomous systems, we get routed directly to the EU server. And the same works within the US. You can have customers within New York and Los Angeles who go through their own ISP. It's likely there's autonomous systems in New York and Los Angeles, and they can all route to the same US server, or maybe you're going full hawk here and you have servers on the East Coast and the West Coast, and those will be routed appropriately as well. And then the same happens for Australia. With just one extra example here is that, Japan, you may not run any infrastructure in the Japan or China or anything like that, but we still want to see as few hops as possible to get it across to that Australian server. Those diagrams make sense? You happy with that?
I think so. The IP address will be the same IP for all of, like, there's one IP that's then being announced from each place.
You're
and that
right.
IP is the same.
Yeah,
IP
yeah.
everywhere.
I should add that to the diagram. All clients making requests for 8.8.8.8 or 1, 2, 3, 4 or whatever. But yeah, you're right. All these clients are using the same IP address to reach different servers around the world. Excuse me. Which is what makes BGP so cool. You don't have to have overly complicated DNS setups. You don't need to have, well, in fact, yeah, it would just be DNS that you did this any other way. But that can be rather complex. Multiplexing, multicasting, your BGP routes are a very clean way to do this. All right.
And that's what's called Anycast?
Yeah. Anycast BGP. I said multiplex, didn't I? Anycast BGP. There we go.
How does that go wrong? What happens if are each of the servers themselves announcing the route to get to them, or is that something that happens at the provider, or what happens when one of the servers turns off?
Well, I mean, we can speak from the Equinix Metal perspective, seeing as we're going to show how that works here. So,
we probably should head to the lab, but okay.
Well, not anybody can just start announcing or advertising BGP routes, right? You can run your own autonomous system for sure, but if nobody peers with you, those routes don't reach the global network. This is where Equinix come in. Equinix have probably one of the best peer networks in the world, which means if you're able to advertise your IP address to them, it's going to go to hopefully most of the autonomous systems on the internet and give you that quick, fast, low hop routing that you really want. But we do see a lot of BGP attacks on the internet as well. I don't know if that's where you were going with your question, but autonomous systems could announce a prefix that they don't actually or can't actually route. And this is usually when you see half the internet go down. It's usually misconfiguration for BGP, right? Like every time a CDN network like Fastly or Cloudflare go down, it's either a typo on their BGP prefix and the traffic gets routed to nowhere. But with Equinix and Equinix Metal, there are tighter controls. There are passwords on the BGP servers. You can only broadcast global IPs. I think we just show how it works, and then hopefully that makes more sense. Because I'm just going to start waffling otherwise.
Nope, that'll work.
All right, so we're going to move on to part 2. And we're going to deploy our first servers. So we're just going to keep this nice and simple for today. Deploy 2 Nginx servers in 2 different metros within the Equinix Metal network and configure our BGP. If you get stuck, there's a video. Hey, that's this video, which you're probably watching right now. So remember to use the code raw code for your credit and start by browsing to the Equinix Metal console and requesting our first global IP. So we can do that now. So from your project, we go to IPs and IPs, request, and you have 2 options. You've got your public IPv4 or the global IPv4. So it is a bit more expensive, but it's totally worth it if you want to keep that latency down all around the world. You can select how many you need. For today, we just need 1. I'll just put course as a tag. And we'll submit our request. Now, if those buttons and options... Sorry, there you go.
Yeah, no, I suppose that stands to highlight definitely in this interface anywhere on the global being on the right side there. Otherwise, BGP you can use locally to inside a single metro or location to swap IPs around machines. But if you're looking to be routable from outside, then got to go global.
All right, let's refresh this page. And I now have my global IP address. Now, if any of those options are not there, what you need to do is go to BGP and there's a button to enable it here. I already have it enabled, but if you don't see the global option, you have to come here and turn it on. Next, we're going to spin up 2 servers. So we're going to use on-demand servers. If you're just playing around, just pick the smallest instance available within the metro. You don't need anything demanding or powerful for this. And just make sure you deploy Ubuntu because all the commands below are for Ubuntu or Debian machine. All right, so I'll do Amsterdam, Ubuntu, and go. Got a favorite region in the US you would like me to deploy to?
I think the closest is going to be Dallas.
Dallas. We can do Dallas. And they've also got C3 smalls. Ubuntu. And go. All right. Those will take 2 to 3 minutes. Oh, go back to the server page. There we go. Yep. Those will take 2 to 3 minutes. So we'll... Maybe I should have done that at the start and then went back to the introduction. But that's all good. So once those come up, we're going to SSH onto them. We're going to run a few commands. Now, our goal is we are going to run Nginx on Dallas machine and the Amsterdam machine, and we'll run curl requests locally, which should give us some simple stats about how long the command took to open the connection, get the first byte, etc. We'll also run a trace route, so you can actually see the hops that the request from my machine takes to get to the server. What we would expect to see is that I hit the Amsterdam server. We can modify the HTML just so that it prints out hi, I'm Amsterdam, and hi, I'm Dallas. But we should see that always hit the Amsterdam server. After that, we'll use, well, I mean, we could curl from the Dallas machine, but I guess that's not going to be very interesting from a routing perspective. But there's a website listed here too, after we get past all the stuff, called Locaping.
I have a computer. I'm in
Yeah.
Texas. I'll give it a look.
Yeah, we could do it from your machine too if you're happy to share your screen. But I didn't want to assume. Uh, we can also use Locaping, which will show, gives us a web interface to traceroute as well. And I think we can select the location that it runs from. So hopefully we'd be able to experiment and see where that goes. All right. The way that we're configuring BGP today is through a piece of software called Bird. This just this handles the BGP advertising from each of our machines to the top of rack switches within Equinix Metal. Those can then publish it to the Equinix network, and then all the routing happens and gets spread to the Equinix peers. We should see this happen really, really quickly. What also might be cool to do, not that I'm trying to go too off script in our demo today, is we should be able to shut down Bird on one of the machines, and within a minute, probably quicker, we'll actually see that our prefix will no longer be advertised within that region, and then it will shut down Amsterdam. And what should happen is I get redirected to Dallas. So we'll see the latency increase, but I'm not losing access to the service. So kind of
That's where I
nice.
was going.
All right. Cool. I didn't pick up on that, but there we go. I'm glad we got there. I'm glad I got there in the end. You just need to give me more hints. That's all. Like I said, I never had that 3 o'clock coffee. Yeah, let's go see where we are with these machines. All right, we've got one, so we can start with Amsterdam first. So we're hopefully going to be able to SSH on. Click the button on my watch. Nice. Probably just do these at the same time. We don't really need to configure both, right? Let's see. Do I have an IP address yet? Yeah. All right. Won't be able to SSH just yet, I don't think. But I'll wait till I'm on it, and then I can broadcast my input to both. Nobody wants to see me input and install these things twice. So. Let's see, how far are we? It could be another minute. Okay, we'll just start. I will do it twice. Maybe the first couple of.
Oh, that'll allow you to make the do a quick twiddle of the. So you don't have to change both of the Nginx hello pages. You'd only have to change one of them, because if the other one was the default, then you'd know.
Yeah, sure. Okay, so apt update, and then apt install Bird and Nginx. We're going to install one more package. Equinix Metal make this really, really easy for us. I don't know why I've not got the link. I'll need to add that. I'll edit it after. The network helpers are an open source repository on the Equinix GitHub. Just some Python scripts that configure Bird for you using the metadata service. So you don't even really need to hand roll your own Bird config, which is pretty nice. All right, let's try before I broadcast my input. Nope. All right. Okay, I can zoom in, or I can change my text size. We're on this profile. And we'll do apt install Nginx Bird. No. Oh no, I have to clone the network helpers, but I do need Python. So I'll grab these two back.
Yeah, you have the link down there in configuring in the configuring Bird section.
All right, let's just do Python 3. Much better. The Dallas box is taking a wee bit extra time. Cool. Now we can jump over here and run this. I'll run through these commands in a second. Let's just write the file first. then we'll open this up because we need to do a small copy or small substitution. So what you have to do with BGP addresses is bind them to the loopback device on your Linux machine. So we have to paste in our address here, which we're going to get from the Equinix page. Okay, it's doing it now. So we go to our IP address and we copy our global one. So and we drop it in. The net mask is there, and we save. And we should be able to just run if 0. Come on, David. What did I get wrong there? Back to my guide. Oh, colon 0. Cool. IP ADR. And we have our BGP address. Now you can just ignore the warnings, errors here. Those are collateral damage. But we do have this, which I think is correct. That is correct. Next, we are going to use the metadata service to pull down some peer information. So I'm just going to copy this. So, in fact, let's just show how this works. Right. So when you're on Equinix Metal devices, you can hit this endpoint. Can't type. Metadata. Did I spell something wrong? Oh yeah, and you get this big massive JSON blob, pipe it through. I don't have JQ. Pipe it through JQ and you get all this metadata from the device. This is all your network information, but more importantly, it has our BGP information. So grep for peer. Why did grep not work? It doesn't matter.
Hey, that's a built-in, at the very least.
I'm assuming JQ maybe spits out the text as standard. No, it doesn't. It goes to standard out. Yeah, I don't know. I can
it should be pretty.
Or maybe
should be pretty printed, but
there's no peer information here. So we've missed a step. Let's make sure BGP is enabled on our device. Disabled. There we go. So I'll add that to the guide as well, and I'll enable it on our Dallas server. Cool. So you have to enable BGP. Now that should be almost instantaneous. So yep, there we go. So if we do the JQ grep again, you'll see that we have a peer autonomous system ID 65530, and then our peer IPs are listed as an array afterwards. And if we take off the grep, it should still be relatively visible. Here, there we go. So we've got our BGP neighbors configuration now. You can see all of this stuff. So we've got everything that we need. We also have access to the server now, so let's get caught up so that I don't have to type everything twice. Update, apt, install, yes, get pipe 3, Python 3, pit, and bird. Cool. And the interface. Moz has a nice tip to use --raw with JQ. Cool.
Oh yeah.
That'll work. Interfaces. All right, so we need to drop it in our BGP address again. Here. Up, low, 0. All right. I think we're in the same place now. So I'm going to broadcast this into to all. Yeah. Okay. Back to my guide. So what were we doing with that metadata? I think this command is actually doing much except for showing us stuff. So let's just run it. I don't have DAQ on the other machine, do I? Oh, the joys. All right. Yes. So this curl is just going to JQ and pulling out the information that we need. So we've got IP addresses, autonomous systems, and we've got the peer IP addresses. So these are the things that we need. Next, we're adding the roots. So let's just do the curl first. So if we paste this, we get a gateway that we need to route our traffic through. And if we run IP route, I think it's handled for us already on these machines. So sometimes what you'll get with, depending on the metro facility, I can't remember how this works, or maybe even the IBX, that you will have to add that route manually. But if you see your gateway listed in the IP routing table, then you're okay. So we can skip that step. Next, we want to configure birds. So let's just do this a couple of commands at a time. We're creating a directory under opt and cloning our network helper. We can cd into that and install our dependencies. Hopefully just works. We can run a configure script, which is also going to write and show us the file using the T command. Whole bunch of stuff there that configures our BGP neighbors based on that metadata that we already seen through the curl JQ command. And next we can restart or start bird in this case. If we run a systemctl status bird, we can see that it's running, and we'll ignore that error. I don't think that is an issue. Confirm this works. Bird provides a console where we can run this command. And it looks good. We have our address, the autonomous system. Things should be cool. Drop it. All right, testy test time. Let's modify var w. Is that a thing? Oh, it is on one of them. Did I forget Nginx on the first machine? Oh no, I'm still in bird. All right. Vim. I need someone to type for me. HTML. Oh no, I don't have it. Var. Oh, there we go. Okay. Default Nginx page. And we'll just change the welcome text. We'll stop the broadcast for a moment. So this first one is Amsterdam. The second one is Dallas. And go back to broadcast. Oh, in fact, we don't need to broadcast now because we've done all the work, as it were. And in theory, and I'm a bit nervous to go running this now, this should work. Let me open it in the right profile. We should be able to do a curl. No, it should be to our IP address.
Oh.
What?
No spoilers. It is working.
Oh, I haven't restarted Nginx. Oh no, I shouldn't have to restart Nginx.
I get welcome to Dallas welcoming me on 147.7540.8.
Hey, look at that. So I am continuously Amsterdam. Wow, we may actually finish this stream on time. I was getting a bit nervous there. All right. let's run our trace route to our IP address. Oh, I really need to copy that without the thing. I'm going to copy it again now because I'll need it a few times. All right, trace routes can take a little bit of time, especially as I go through my ISP's network, which does not respond to ICMP pings, which is what those stars mean. It slows down the entire trace route because it's going to do it 3 times before it gives up. And I think it's going to do that a bunch of times. Is there a command with traceroute to just do 1 ping and give up? I don't know.
1 ping only? I believe so. I can't remember what it is offhand, but
Trace. Yeah, I'm not. Oh, yeah, -q queries. Let's try speeding this up then with a 1. And if that does 3 stars, I'll be mighty unhappy because I'll set us back about 20 seconds. Good. That'll speed it up a little bit until we get outside of my very opaque ISP 5G network. How's the trace route? Are you doing a trace route too?
Same.
All right.
I'm getting about 8.5 milliseconds over here.
All right. I mean, that looks like we hit the network. What's it done now? Oh, I don't know. All right, 15 hops.
Did you fire off ping first? I went ping first, which gave me the yeah. So 12 hops over here.
Cool. So we got our hops. We can see the trace route. I actually thought we'd see some of the. Normally, when I do a trace route, we see some of the IBX information, like, oh, you've hit Dallas and you're going through this metro facility. But not today. But that's okay. But we got nice low ping, and it works. So before I go shutting down our bird on Amsterdam, let's try Loca ping and see what this gives us. Cool. So we can drop in our IP address and let's hit this from somewhere that might be. Yeah, I don't know where Singapore or Hong Kong will route to. Oh, and this isn't going to show us the HTML, so who knows? Oh, no, wait, we can see. It gives us country information. Is it finished? Yeah, it went to Dallas. There we go. Although it's in New York, but I'll assume Dallas, right? Let's try that again from France. See if it's different. Oh, it's doing it from both. Oh, that's cool. Well, we hit Dallas again over here. I don't think the one on the right is finished. All right, let's enable a few more. Screw it. Spain, Italy, Netherlands, USA, go. All right, so Dallas hit Dallas really quickly. Amsterdam is in America. Interesting. Oh, they're all going there. Oh, no, except Milan went to. Yeah, maybe that website works. I'm not sure. Let's do another test. Let's shut down Bird. Stop. In fact, let's shut down Nginx too. So we should have nothing running here. And if we do a curl, I had Dallas. I was expecting more things to go wrong.
Yeah, I was trying to figure out exactly what would happen then if it would immediately fail over and send you to the correct one, or if any additional intervention would be required.
No intervention should be required, because when Bird stops advertising, the autonomous system in that region will just drop the prefix. It's really quick. I remember Dan doing some tests with his open source project, KubeVip, and I think he said he got it. He said it was like 3 seconds for the failover and the prefix to be dropped. So it's super fast. And the fact that I could just curl, and even though it's a bit longer to Dallas, we're seeing the 132 milliseconds ping instead of the 30 milliseconds ping. At least I'm still getting a service. So what we're seeing is BGP is great for globally routing traffic to your customers, at least to a data center or server as close to your customers as possible. But as a happy side effect of this, should you happen to lose any of those advertisements, the global network can reroute you to somewhere else. Maybe a good experiment for this, if we ever do a re-recording of the first part, would be to do 3 or 4 servers and shut them down strategically to see where I'm going to be routed through. But I think for today, this is a success. So we'll jump back.
It should continuously go from wherever you are to next fastest or fewest hops. But yeah, it'll be a quick, fun experiment.
Yeah, if I can't be routed to Amsterdam, it would likely route me to Germany if I had one there. If there was nothing in Germany, maybe it would go to the next closest. Yeah, the network handles this for you. Especially, this is why it's important to be on a network like Equinix, where they have these peers, they have the backbone, and the intelligent routing should be there for you. So I hope people find this useful. Feel free to jump on the Discord if you need any support, advice, or questions. Thank you, Jeremy, for joining me today. We've got 1 minute left. Any last words?
Absolutely. Thanks for absolutely. Thanks for having me, and I look forward to the following portions of the course.
Yep. The next part of this course, we'll be back next week. We're going to deploy core DNS globally using the same setup. We're going to do this 3 times for 3 different pieces of software, just to show you why it's important, how to keep those latencies down, and scale with your customers. So tune in then. We'll see you all soon. And thanks again, Jeremy. I'll catch you in a bit.
Absolutely.
Bye.